We are now at the top of page 656. This is lesson 10-1, video 3, and we're going to be studying cross sections. This should not be a long video, but I will tell you that for some of you it's going to be harder to envision this than others. It's not, well, some of it is very easy for me to envision. Other parts that we'll do at the lower part of the page are definitely more tricky for my brain. So let's just work through it together and then do the best you can on that part of the homework. Take the time to try to envision what you're looking for. Remember, geometry is very much about us needing to be able to visualize. All right, so let's read the definition at the top. A cross section is the intersection of a three-dimensional figure, and we've been studying the three-dimensional figures this whole lesson. So it's the intersection of those figures and a plane that we almost use to cut through the three-dimensional figure. Let's look at example A to start understanding that. Describing cross-sections of a three-dimensional figure. Describe each cross-section. So basically what that means is we're going to tell what shape the cross-section is. So if you look at this triangular pyramid, ignore the thing sticking out of it. Just picture the purple pyramid without that. We can tell it's a triangular pyramid because it has a triangular base and triangular sides that meet at a common vertex. So it is a triangular pyramid. If we were to take let's say a piece of glass, a flat plane of glass, or a flat plane of any material, which is what this beige square represents, if we were able to slide it through this triangular pyramid, if we were able to slide it through parallel to the base, what shape would we be left with in the middle? That's called the cross section. That's kind of like if we could take the bottom of the pyramid away from the top of the pyramid and look at the surfaces that we cut right there. So we're looking to see what that shape is, and it's a triangle. Now let's look at the cylinder. Well, actually, I don't need to move the phone. It can stay still. All right, if we were to do the same thing here, cutting parallel right through this cylinder, this one's pretty easy to envision. That would leave us a circle in the middle. Or if we picked up this top part and looked underneath it, we would see a circular base right there as well. So the cross section is a circle. Let's look at this hexagon, or hexagonal prism is what this is, below in 3A. Again, if we were to cut right through or take a cross section that's parallel to these bases, what shape would it be? It would simply be a hexagon, just like the two bases. And thirdly, or this is kind of fourthly, if we look at 3B, we have a cone, a circular base, and a curved section that connects the base to a vertex at the top. If we were to cut vertically right through this shape, as this picture shows, what shape would we see in the middle? We would see a triangle, and you can see how they've drawn that in there. So that does take some visualizing for sure. Let's take it to another level in example 4. A chef is slicing a cubed watermelon for a buffet. How can the chef cut the watermelon to make a slice of each shape? All right, so the first one's pretty easy. We want to make a square shape. We want to do a cross section or a cut that's going to give us a square. That's easy because this is a cube. So we know that every side of it is a square. So if we just cut parallel to the top and bottom, we're going to have a square. More tricky would be example B, and this is to make a hexagon. In order to do a hexagon, and let me just assure you that I could not have visualized this probably on my own. In order to make a hexagon, we're going to do exactly what they tell us we're going to do. We're going to cut through the midpoints of the edges. So we're going to cut through here. We're going to do a slice that runs here and here. So our knife would be placed between those two midpoints, and it's going to go at an angle, and it's going to hit this point, and then it's going to hit the back two midpoints of the bottom of the watermelon, which you can only see in this 3D picture. So take a minute to visualize that and see if you can see how we get a hexagon by cutting there. If you can't visualize it quickly, just pause the video and look at that. Again, I told you that would be challenging for me. The next and last thing that we want to look at is check it out 4. How can a chef cut that same cube-shaped watermelon to make slices with triangular faces? Well, let's look at the watermelon and I'll tell you what I was thinking, and then I'll tell you what the book was thinking, or the answer key. Let me get this a little more stable. Okay, that should do it. All right, what I said is for us to cut from the upper front vertex. So I'm looking right here, this upper front vertex, through to both lower middle vertices. So I'm going to cut from here back to there at an angle. So in the beginning, my knife would only be cutting through that one vertex. But then as it went, it would be cutting back through here to the lower. Actually, those would kind of be the lower middle vertices. They're not the front and they're not the back, but the 2 side vertices. The answer that the book gave said cut through midpoints of 3 edges that meet at one vertex. So cut through midpoints of 3 edges that meet at one vertex. So here's a vertex. Here's 3 edges that meet at it. 1, 2, 3. And we're going to cut through this midpoint, and this midpoint. So obviously we're going to have to put our knife through those 2 at the same time and then come at an angle towards this front one, and that should give us a triangle as well. All right, I hope this all goes well on your homework. You have kind of a lot of problems, but many of them will not take you any time at all, hardly. So some of it you should really be able to move through quickly. Just give your best on it, and I will look forward to seeing you in the next class.